Hello, my name is Andre, and today I'm going to show you how to convert Talos control plane, which is running as self-hosted control plane, to the static pods. So this is a specific item after upgrading Talos from version 0.8 and below to Talos version 0.9. So Talos before version 0.9 was always running control plane as self-hosted, which means that Kubernetes itself was running Kubernetes control plane. It was running basically as daemon sets in Kubernetes. Talos 0.9 comes with the new way to run a control plane as static pods. This is much more flexible and much more robust way to run Kubernetes control plane because it doesn't depend on itself to be up, which means that it's much easier to fix issues with the control plane if some configuration change goes bad, or to not to rely on the control plane to run itself, which is a big help for single node control plane clusters, non-HA scenarios. But let's start. So first of all, let's refer to the documentation for this process. Uh, this documentation lists the steps which we need to take. First of all, we're going to make sure that we have all the Talos nodes upgraded to the version 0.9. We'll start the conversion script. The process is fully automated. In the middle, we're going to stop the script and check the generated uh, static pod definitions and bootstrap manifests. And after that, we'll continue with the script and get the control plane converted fully. So let's get started. I have a Talos cluster, which consists of 4 nodes, 3 master nodes, and 1 worker node. And this cluster is now running Talos version 0.9 beta 0, the latest one available at the moment. And I'm going to first check the self-hosted control plane status. I can do that with talosctl by getting a resource called bootstrap status. And I can see that the self-hosted status is true at the moment, which means that Talos got upgraded from version 0.8 to 0.9, but it is still running the self-hosted control plane as it was in 0.8. On the left, I'm going to use the console on the left to enter commands and run commands. On the right, I have a watch command doing kubectl get pods, which I will use to show you how the conversion process is running and also to show that the control plane is available during the conversion process itself. So let's get started. I need to start command called convert Kubernetes, and I'm going to tell it the node it should connect to. It should be one of the control plane node. I'm going to use the first one. So let's start this process. So first, script discovers my cluster. It discovers the control plane nodes. It looks into the current configuration of the self-hosted control plane and gets the configuration from it and merges it back into the Talos machine configuration. As Talos is going to run the control plane on its own as static pods, and static pods are run by the kubelet, but the definition of the static pods is going to be rendered by Talos. The machine configuration should be updated for some missing elements so that Talos can successfully generate the static pod definitions. So at this moment, script stops and asks for confirmation whether we would like to proceed, but it also tells us that we should probably take a look at the static pod definitions and the manifests to see whether the generated data looks good before we proceed with the conversion. So let's stop at this moment. I'll enter no. And I can actually look into the static pod definitions. So let's look on the first control plane node. I have three static pods for each of the Kubernetes control plane components. Same on two other control plane nodes. And I can also look into each definition by adding the flag -o YAML so that I can see the full static pod definition. So it contains all the arguments. They were generated from Talos machine configuration. And if the control plane configuration hasn't been changed since the time it was initially bootstrapped on Talos 0.8 when it was self-hosted, there should this definition should be okay, but it should be still checked for like some missing pieces or whether some configuration like feature gates or something else was added after the control plane was bootstrapped. So I can check the Kube API server, the Kube controller manager, and the Kube scheduler static pod definitions. They should match the pod definitions of the self-hosted control plane running as daemon set today. So once I verified those, I can look into the Bootstrap manifests. Bootstrap manifests are additional resources which are injected into the Kubernetes API on Bootstrap. And these resources are also injected by Talos running control plane as static pods. But as these resources might have changed over time, we need to make sure that they look good. Once again, I can check the list of the manifests and check each manifest specifically to see if there's anything missing. I can add -o YAML and check the manifests whether these definitions look good, whether CNI is matching my expectations. In my case, I'm running Flannel, the default, but if running other CNIs, there should be other definitions for CNIs like Cilium or Calico. So this looks good. I should have checked the definitions on all the control plane nodes to make sure that machine configuration is in sync between them. But in my case, I know that the config is good. Let's take last look at the self-hosted control plane. So it is running as daemon sets and the Kube system namespace. I can see the Kube API server, Kube controller manager, and Kube scalar components, which are going to be converted to the static pods. There is also a daemon set for the pod check pointer, which will be removed completely. This component improves the resiliency of the self-hosted control plane against reboots and failures. We don't need it anymore. It will be removed. And Kube proxy will stay as a daemon set as it was. And the Kube flannel is the CNI daemon set. It will also stay same way as it is right now. So let's restart the conversion script now that we have everything verified and answer yes this time. So right now what is going to happen is that script is going to remove the pod checkpointer component and will wait for the checkpoints that were created by the pod checkpointer to be fully removed. So I'm going to answer yes. It says deleting daemon set pod checkpointer, and you can see on the right that the pod checkpointer pods are now removed, and the only pod checkpointer pods still running are the checkpoints of the pod checkpointer itself. And it will take 5 minutes before these checkpoints will be removed completely. That's how pod checkpointer works. So I'm going to pause the recording and get back to you once this process is complete. Let's get back. So we can see that the pod checkpointer checkpoints got removed. There might have been other checkpoints of other control plane components. They should be removed by this time. And script asks us once again for confirmation whether we are ready to apply the new static pod definitions and manifests? We're going to answer yes. At this point, script removes the self-hosted status, so Talos no longer considers control plane to be self-hosted. Talos released the static pods, and we can see them running here. And it's now what it's doing, it's deleting the old daemon sets for the Kube API server, and the new static pods are taking over the Kubernetes control plane. Uh, at, at first, when the Kube API server is getting launched, it can be launched because it tries to listen on the same port as the old self-hosted Kube API server, so it will be restarting. But once the self-hosted Kube API server is removed, the new static pod-based Kube API server takes over, and we could see that there was a brief disruption in the control plane when the Kube API server was uh, being removed. And now all the self-hosted daemon sets got removed, and we can see that the new static pod-based control plane components are running, and our control plane is still up and healthy. And that basically concludes the conversion process for us. Thanks for watching, and links to the documentation will be available in this video description.